Today we are going to solve LeetCode number 323, number of connected components in an undirected graph. Here we are given a graph of n nodes. There is also an array for the edges. Every index of edge will contain two indexes, ai and bi. This indicates that there is an edge between ai and bi. We have to return the number of connected components in the graph. From the example, we can see n is 5. That means there are 5 edges, 0, 1, 2, 3, 4. And this is the array of edges 0 to 1. That means 0 is connected to 1, 1 is connected to 2, and there is a connection from 3 to 4. So now you can see these 3 edges are connected, these 3 nodes are connected, and these 2 nodes are connected. So there are 2 different components. So the answer is 2. Now from the second example, we can check that all the vertex nodes are connected with each other. If you start from any one node, you can go to any other node using a DFS. So all the 5 nodes are connected as one component. So the answer is 1. Now, how do we solve this problem? Let's say this is a graph given here. The component number is 0 right now. So we'll start a DFS from node number 1, and all 3 of these will be visited. So there is one component, this. So we'll increase the component variable. Now we'll go to 4, and then it will visit node number 5 with another DFS traversal. Now we'll come to this part. We'll start from 0, and all of these 4 nodes are visited, and the component number is 3. So we'll start from the nodes, and then we'll start a DFS, and the nodes that are already visited will not count them, and thus the number of components will be calculated. Now we are moving to the coding section. So here we will need a visited array which will be tracking the states of the nodes, if they are visited or not, and then will be needed an adjacency list. We can use adjacency matrix as well, but that will take more space, so we'll use adjacency list here. Now we will create adjacency list traversing the edges vector. As this is a undirected graph, if 0 is connected with 1, 1 will also be connected with 0. So that means we will use both the nodes as their connected components, as their connected nodes. Now, after creating the adjacency list, we have to traverse the graph using DFS. So this is our main logic. So if on node we have been given in the, according to the problem statement, there will be n nodes and the numbers will be 0 to n minus 1. So we will traverse from 0 to n minus 1. That means till smaller than n. And if the visited index is 0, that means this node is not visited yet. We will call a DFS for that node, and for every time there will be a defined number of components. Now we'll go to the DFS code. So here you can see, as soon as any node is visited, we will keep track of it in the visited array, and then we'll check if from the adjacency list, we'll check if the connected nodes are not visited. If they are not visited, we'll call another DFS for that node as well. Thus, we'll come back and we'll do it again, and as the loop ends, whatever the number of components we have, that will be stored in the answer ans variable, and we will return that variable. Now we will run the code. You can see that is accepted. Now we will submit the code. As you can see, this is accepted. Here is the time complexity. It's n plus e, that means the number of nodes and the number of edges, and the memory, the space complexity would be same, n plus e, that means the number of nodes plus the number of edges. If you like the content, please share and subscribe the channel Design Your Thought.